Couple quick logistical things before we get into the lesson. First of all, we are more than halfway through with the online learning. This is our 6th of 10 lessons, so keep plugging away. You guys are almost graduates. Second of all, make sure that you are submitting these assignments on time on the day that they're assigned and due. And if there are any issues, don't hesitate to reach out, but otherwise we are going to start taking off late points. And for the quizzes, I did see a good handful of people opened the quiz and then closed it and then did it some other time. So just make sure that when we have the Chromebook locked quizzes, that you guys are just doing it all in one go. And there's only one more quiz, so just make sure that you are following that procedure for that one, okay? So our final topic of the school year is called Redox Chemistry. We're going to be following along with this PowerPoint. You guys have this on the Google Classroom, so if you want to go through the slides yourself slower, that's totally cool. All right, and we're going to be doing an experiment where I make a penny and turn it into silver and gold. Very fancy. So here's the silver and gold pennies. We're going to go through how we do that, okay? So first of all, what does redox stand for? It's a combination of two words put together. That's called a portmanteau. So reduction plus oxidation, those are chemistry terms. Put those together and we get the word redox. So here's a couple other combination words that you guys are probably already familiar with. Breakfast and lunch. Shaq's favorite meal of the day. Spoon and fork make spork. And lion and tiger, liger. That is a real animal, although don't be like the guy in Tiger King. Okay, so our first word there is oxidation. So this unit, we are going to be relying on some prior knowledge from earlier in the school year. So if you think of sodium, it's in this first group, which hopefully you remember is called the alkali metals. And all those elements, lithium, sodium, potassium, they do this characteristic reaction where if you put them in water, they go fizz around on the surface and then sort of catch themselves on fire. And what's actually happening there is that the sodium metal is becoming oxidized. So we'll go through exactly what that means. So sodium and all of its alkali metal friends have one valence electron. So what do you think they are going to do with that valence electron? Go ahead and answer the question. Hopefully you said that it is being lost. It's being given away to some other element. So when sodium loses its outer or valence electron, it becomes a positively charged ion. So that process of losing an electron like sodium does is simply called oxidation. So we're going to see that these redox reactions are driven by one element that loses its electrons and the other element is going to receive these. So a fun way to remember that, here she comes. Shout out to Brianna for getting some extra credit.
Leo the Lion says, grrr.
All right, we had some technical difficulties there, but there's the saying. Leo stands for lose electrons oxidation, so that's the way to remember that. And then GR, if we gain electrons, we're being reduced. So on the next slides, we'll kind of talk through what that looks like. Here's an element that loves to be reduced. Bromine is in the halogens. So we can see that when in this reaction is with aluminum. So when you take bromine, which is a kind of a gross looking liquid, and react it with aluminum foil, it's going to also catch on fire, and the bromine there is being reduced, which is the exact opposite of oxidation. So hopefully you can put the pieces together there and answer that question. So Leo the Lion says, GR, gain electrons, is also known as reduction. So the element that's gaining electrons in the reaction, we say is reduced. So here in this little animation, let's actually make it bigger. Sodium is being oxidized, giving its electron away. Fluorine is going to be reduced. So the reason that it's a combined action is you can't do one without the other. If you got a redox reaction, one's being reduced, one's being oxidized. All right, so the next thing we're going to take a look at is called half reactions. This is a way to write out what's going on in an oxidation or a reduction, just focusing on one element. So let's start over here with a reduction because it's a little easier to see. Like we just said, bromine likes to be reduced. Remember, that means gaining electrons. GER, G-E-R, gain electrons reduction. So if you're writing that out as a chemical equation, Br plus, this little symbol here is new, right? E minus, that's not an element, that's an electron. So Br plus an electron, when it gains that electron, it turns into bromide, which is Br with a negative charge. Oxygen says something really similar, but it needs 2 electrons to fill up its orbital. So O plus 2 electrons turns into O2 minus. So notice that in all the reduction examples, the electrons are on the left side, like a reactant, because they're being added to the element. They're part of the ingredients, quote unquote. Oxidation, we can see it is the opposite situation. So we start with the element, and as it becomes oxidized, it's losing either 1 or 2 or sometimes even 3 electrons. So since those electrons are being lost, they show up over here on the right side of the equation. And notice that it becomes a positive charge. When it's being oxidized, its charge increases. So Mg turns into Mg2 plus 2 electrons. So let's do one from your worksheet together. I think that might be helpful. So if you want to do this right along with me, that's fine. If you want to just watch it and do it later, that's also cool. So we can see the first one's already done as an example, but the second one is asking us to do the oxidation of rubidium. So the first thing you need to look up is rubidium's in the first group, so it's got 1 valence electron, and it's going to give that electron away to some other element. So we can imagine that happening, but to write it, we're going to do Rb turns into Rb plus, right? When you lose an electron, you become positive, plus 1 electron. All right, and keep in mind, you don't need to write the 1, you can just write plus E minus for the symbol there. Okay, so make sure you're thinking about how many valence electrons it starts with, whether it gains or loses, and how many. And it's just kind of a new, more formal way to write that, but the idea should be pretty familiar to us from earlier in the school year. All right, I got some goggles on. Safety first. This is actually a very strong solution that we're going to be working with here. The ingredients in this gross looking mix are sodium hydroxide, water, and zinc metal. Okay, so the instructions are basically take a really clean penny. So I soaked this penny in some vinegar and salt to really clean it up. Where are you at, penny? There it is. And then that nice shiny clean penny is going into our mixture. And I've had a couple already sitting in here, so we can pull one out, but it takes about 2 to 5 minutes. And there's a chemical reaction that happens. So let's pull one out. And we can see that we have ourselves still a penny. But does that look like a penny anymore? Not really. Try and get that visual a little bit better. All right, I'll show a picture of it in a second, but we got ourselves a nice silver penny. And let's cool it off and clean it off in some water and remove my beaker. And our next step, we're going to take our silver penny and put it directly onto the hot plate. It's going to hop around because of the water. Just got to boil off that water. And then let that penny just sit there. Let's zoom in our camera.
What I like, I do. What I like, I do. I do. What I like, I do. I do. What I like, I do. I do.
All right, that looks pretty good. So we've got ourselves a nice gold penny to add to our silver penny. Out of the way. And those are good to go. Take those babies to the pawn shop. All right, last thing we are going to cover is just what exactly happened here. Hopefully you got some good guesses that you made in the questions. For the silver step, the copper from the surface of the penny is being turning into copper 2 plus and losing 2 electrons. And the zinc already was in the solution as Zn2 plus. It gained 2 electrons to turn into zinc. So see if you can figure out which one's oxidized, which one's reduced. There's your answers. So again, keep in mind, lose electrons oxidation. Notice that the electrons over here on the right side. And then gain electrons reduction. Leo the lion says grr. Something that might look a little bit different in this one is that it didn't start out neutral. The zinc started out charged, and by being reduced, it turned into normal metallic zinc. That's the silver color that we see on those pennies. So silver penny, right? It's silver because it's got zinc on it. And one way that I like to remind myself what these mean, notice that it started out +2 and it ended up neutral. Its charge reduced. So when you see the charge go down from +2 to 0 or any decrease of charge, that's a good clue that you've got a reduction. The final step, the gold penny, this doesn't really have anything to do with the lesson, but just for fun, what's actually happening here is that we didn't actually make gold. We made something called brass, which you've probably heard of. It's made of trumpets and trombones and saxophones and those type of things are brass, and it's simply a mixture. So you might remember from earlier in the school year, that's a homogeneous mixture. The copper from the surface of the penny and the zinc that we just formed are able to mix together, kind of just spread those particles within and around each other. They're not reacting, they're just mixing. And that's what made our brass, which is that nice gold color that we see on the penny. Okay, hope to see some of you guys at office hours, and I will talk to you soon. See ya.